This is one of the experiments results that I am working on. In this experiment, we have a major aim of producing fill lines. On this part, you can be able to see a negative sign, and here is a positive sign. So what we basically did is to have this wrapper sheet, a very thin wrapper sheet, on which we placed a magnet on this end and another one on this end. Then we connected a source of direct current to this magnet, and the other pole of the electric source connected here. So to this point we connected the negative sign of the P3 and this one positive sign of the P3. We basically used two cells of each 1.5 volts. Then the whole system was placed on a metal sheet made out of steel. So we had a steel sheet. Over it we placed a tracing paper, then this rubber sheet. The rubber sheet, when it is thin enough, it can be able to conduct electricity. So once you place the magnet here and another one here and connect the power source, what happens is that electricity tries to flow through this rubber sheet. Now the pulling paper between the tracing paper and the metal sheet cannot allow electricity to flow onto the sheet. So what we do is we start from somewhere the middle here. We shall place a point and we shall use it as our reference point for the middle part of the paper. So before we can be able to fix the reference points, what we do is to measure the potential difference between the positive pole and the negative pole. After that, we can divide the voltage by 20 to roughly get how much of the spacing that we require, so that we have at least 20 field lines, or sorry, the equipotential lines. Then once we obtain the voltage difference, we can start from N1 point, say the positive side, measure a voltage corresponding to what will be the total voltage across the two poles divided by 20. For this case it was about 0.2. so if you space it by 0.2, what you get are about 20 equipotential lines. Then say you start at this point, which will give you 0.2 volts. What you do is you place one of the surge pins, the surge probes of the multimeter, the digital multimeter. Then you move the other free end along the rubber sheet to find a point where the reading on the digital multimeter is 0. It will actually mean that the point is on a equipotential line, as the other point you had fixed is, as your reference point is. Then you find other points near this region that give you 0. So that way you can be able to find the points. When you find the points, use some little more force to press through the rubber sheet, so that it makes a mark on the tracing paper. After you are through with the first reference point, you can move to a second reference points. For easy of work, you can prefix the points, like if you had the magnet here, you can put points at the steps of 0.2 folds from one another, so that you get about 20 reference points. Then once you finish with one reference point, you move to the next reference point and you find the equipotential lines for each. It may also be good practice if you start from the middle and find the equipotential line based on the middlemost reference point. It is also very good practice to have the search points as close as possible, so that you avoid cases where you may get that due to the field strength, the equipotential lines bend. After that, you can move to next point. If this is done for many points, what you obtain is a set of points on the tracing paper. Now, if you join all the points that seem to be on the same line that produced zero potential, what you have are curved lines like this, with the middle part having a line that is almost straight. The two on either side bend slightly. Then as you go closer to the poles of the electric poles, what you have is more curved lines. That the electric field is more felt near the terminal